Section 6.2 is about transforming and combining random variables. So we're going to start with transforming them. And by transforming, I mean multiplying by something, dividing by something, adding something, and subtracting something. So for the first thing, we have a few rules, and these are going to look kind of familiar. You've seen them before. So first of all, when you're multiplying or dividing something, let's say we're doing this to a random variable, and we're going to call the random variable x. So what's going to happen is that all values, all measures of center, of location, and of spread will be multiplied by b. And by location, I mean things like Q1 and Q3. Those are locations. So those are just points that are a part of the distribution. By center, remember, I mean mean and median. And then spread is going to be the IQR and the standard deviation. So in this case, you're generally going to be working with random variables. You almost always are going to be only working with the center, or the mean for the center. So for example, your new mean is going to become b times your original mean. This is my new mean. And your new standard deviation is just going to be b times your original standard deviation. The other thing that's going to happen is if you multiply or divide by something, the shape is not going to change. So if you were to have a histogram and you were to draw all of your values in your histogram, and then you multiplied something by all the values, the histogram would have the same shape. Okay, so when you add or subtract a constant, what's going to happen is measures of center and location change. However, measures of spread don't change. And the center and location are going to be either A is added or subtracted. They change by A. And we'll do some examples of this in just a sec. And as with the multiplying and dividing, this shape does not change. Okay, so the next one, I put if adding and subtracting, but actually I meant to write if adding and multiplying also. And it will also apply for subtracting and dividing, but you usually, more often than not, you're going to be adding or multiplying something. And what I mean is you started off with your random variable x, you end up changing it to y equals a plus b times x. So what I mean here is I multiply all of my values by a constant b, and I add a constant a to everything. So what's going to happen is this shape stays the same. And this is just like an important random thing that you're probably not going to see in the scope of this class, but you might encounter it in the future. Just to be thorough, this is only true if you multiply it by a positive. But like I said, you're probably not going to encounter that. Your mean, I'm going to write out the formula. What's going to happen is the mean of your new value is going to be, A is going to be added, but B is going to be multiplied by the original mean. So I know the formula is a little bit confusing. All it means is that the mean of your first variable is multiplied by B, and it's added to A. Your standard deviation is just going to be multiplied by b. As with the previous thing, just to be thorough, we're assuming b is positive, or you can think of it, you can add absolute value bars. But if you don't remember about the absolute value thing, like the stuff I put in black here, don't worry too much. It's not going to be something you're going to encounter very often. So let's go ahead and try this first example. So you'll find pretty much, I think almost all of the examples that you're going to see in this section have to do with El Dorado Community College. So they're telling you that a student is full-time if they're taking between 12 and 18 units. They are going to define the random variable x as the number of units that a randomly selected student is taking. And it has the following distribution. So what we're going to do is we are going to start by finding the mean and the standard deviation, and we're going to also make a histogram. So for this, do not be confused because this is not doing any sort of transformation. You're not going to use any of these formulas yet. The mean is the same thing as you found in the previous chapter. You're just going to do 12 times 0.25. You're going to do 13 times 0.1, and so on. I'm gonna just do ... You are perfectly permitted to do like this ... in the middle to show that you did everything in between. You don't have to do write all the work out. If you want to do it on your calculator, what I wrote down here is sufficient for showing work. You will find, and I do recommend that you try this on your own, by the way, you will find that your mean is going to be 14.6 units, 14.65 units. The standard deviation is yet another thing that it's a little bit more complicated, but it's the same thing that you had in the last section. I highly recommend that you do it on your calculator so you can get the practice with it. I'll write it out here, however. So your standard deviation is going to be the square root, and it's going to be a long square root of, first of all, you're going to do your number of units. I'm going to start with 12 minus your mean that you just found, 14.65. You square it, and then you multiply it by the probability of the next thing. Then you're going to do the same thing with 13, 14, 15, 16, 17, and 18. What I'm going to do for showing my work here is rather than writing everything out, I'm going to do plus ... and then I'm just going to do the very last thing. And I'll put 18 minus 14.65 squared times 0.15. And you'll find that your answer for this one ends up being 2.06. I highly recommend that you work this out on your calculator on your own, but if you don't, I kind of don't blame you. It's really long. You're not going to have to do this calculation very often. It's going to rarely happen. Most likely, if I give you something like this, it'll only have about 3 numbers, just because it's a long thing, and people tend to make a lot of mistakes on these. So I'm now going to draw the histogram for part A. And the histogram for A is going to look like any other histogram that you have, except that we're going to be centered around each of our values. Also, on our y-axis, we're going to have our probabilities. So our x-axis, make sure you label it, is going to be number of units. The y-axis is probability. And I do not need to go up to 100%, or I do not need to go up to 1. I'm just going to go up to the highest things I have. So for 12 number of units, the probability of that happening is 0.25. So I'm going to start with that one. For 13 units, the probability of that happening is 0.1. And so on. So you're going to be doing the same thing. Sorry that mine isn't perfectly spaced. Make sure when you're doing a histogram that the bars are touching each other. That's very important. Otherwise, it ends up being a bar chart that looks kind of weird, but it's not a bar chart. So just make sure that you are making all of your bars touching. So now we're going to do part B. what they tell us for Part B is that the tuition for full-time students is $50 per unit. We're going to start by finding the probability distribution for the tuition, and we're calling the tuition charge T. Actually, the probability distribution for this, believe it or not, is really easy compared to some of the things that we have to do. So what we're going to do, all you need to do, you keep the probabilities the same. 12 units, all you do with the 12 is you multiply that by 50, and you're going to do the same thing for all of these. All you do is you multiply each number by 50, and that's going to give you, this shouldn't be number of units, actually this should be tuition. Sorry, that was my mistake. Each of these, you're going to have the same probability. You just take the original and you multiply it by 50. So that's all our new probability distribution is going to look like. And your probabilities do not change. The only thing that changes is that your units get multiplied by 50 and they now are the tuition. For Part C, it asks you to find the mean, standard deviation, and a histogram. So now, for the mean and standard deviation, you have two options. You can either take what you just did, your probability distribution, and you can calculate the mean, which is the expected value, using the values that you have. The other option is that you can take the original mean that you had, I'm going to call that mu of x, and all you need to do is multiply that by 50. So our original mean was 14.65. And it is going to be $732.50. If you want, you have the option of checking your work by taking the probability distribution that you wrote in B and finding the expected value of that. You'll get the same answer. And because it's multiplication, our standard deviation is actually going to be the same exact idea. You take your original standard deviation, you multiply it by 50, it ends up being 103, and it is dollars still. So that's going to be the same. The other thing that's the same is the histogram. I'm not going to draw the histogram, but what I'm going to tell you, I'm going to actually direct your attention to the histogram that we have above. It will be exactly the same shape. Nothing changes except that these numbers are now going to become just multiplied by 15. So it will be the same exact shape. You don't even need to do that much different. To be honest, when I give you a quiz or a test on this, I'm not going to ask you to draw a histogram, most likely, but it is an important thing that you kind of understand that the shape does not change. So for our next example, we're going to take the tuition that we had in the previous one, and now what we're going to do is we are going to add a $100 fee to it. So this is kind of taking, remember that the T in the previous thing was 50 times X. So it's kind of doing a combination of multiplication and adding. So what you're going to do for the first thing, you are finding a probability distribution of your overall cost. And I put the distribution that you had in Part C. All you're going to do is you keep your probabilities the same. You don't change anything. All you're going to do now, though, is you're going to just add 100 to each value. So then nothing else will change on that. So that's all we have. Okay, so then the mean and the standard deviation. So previously, we had the mean of our T. We had taken the 14.65, we'd multiplied it by 50, and we ended up with $732.50. Now what you're going to do, your new mean with the C, with the overall cost, all you're going to do is take that and add 100. So this is very nicely straightforward. You don't need to do anything other than just adding the 100. Standard deviation. So the standard deviation we had from the previous thing was $103. So actually the standard deviation of the cost, remember what happens with measures of spread, it will not change when you add something. So it is also going to be 103. So you only are going to multiply in that case. In this example, we have defined X as the raw scores on a stats test. And they tell us that X has a mean, I'm going to call that mu sub X, of 17.2, and that X has a standard deviation of 3.8, which is sigma sub X. What they want to know is what's going to happen when a professor scales the scores by multiplying the scores by 4 and adding 10. So what we're going to do is we are going to let Y be our scaled score. The way that Y is going to work out is Y is going to be multiply X by 10 and then multiply X by 4 and then 10 is going to be added. So it's kind of like we're doing 4X plus 10. So now what you're going to do, in order to figure out your mean, the mean of Y, you are going to take the mean of X, which is 17.2, you multiply it by 4, and then you're going to add 10. That is going to give you 78.8. Now, the standard deviation, remember with standard deviation, adding doesn't change anything. So all you're going to do is take your standard deviation of 3.8 and multiply it by 4. You do not add 10. So in this case, you're going to get that your standard deviation is 15.2. All right, so then the last question on this example is that what is the probability that a randomly selected student has a scaled test score of at least 90? So what we're going to do now is we are going to draw a normal model. We know that our mean is 78.8, and we know that our standard deviation is 15.2. I'm going to put 90 right here, and we're going to look for the area above that. So the way I'm going to write this out is as the probability that Y, my scaled score, is greater than or equal to 90. So it's important that you try to write out this notation properly. It helps your, first of all, on the AP test, they actually are looking for that. But it's a good thing to do. It's statistical notation. It's a good habit to get into. So then we're going to do normal CDF. And we're going to start at 90. After 90, you can do any huge number. I'm going to do like 1,000 or something, but you can choose any big number that you want. Then you do your mean, which is 78.8, and your standard deviation, which is 15.2. So from there, you will end up getting 0.231, and that's our probability.